A high-speed circular saw slicing into dry concrete generates a dense, rapidly expanding cloud of airborne particulate. In UK construction, the hazards that cause the highest number of long-term occupational fatalities share a specific physical characteristic. They are microscopic and often completely invisible to the naked eye. These threats arrive in distinct forms: solid dusts and fibers, liquid mists, condensing fumes, vapors, gases, and biological agents like bacteria and fungi. For the NEBOSH examiner, simply stating that dust is a hazard is an immediate failing answer. A passing answer requires precision. You must define the agent's exact physical form, map its route of entry into the worker's body, classify the specific resulting health effect, and deploy a proportionate control measure based on the hierarchy of control. Occupational disease is a highly predictable pipeline, operating from the point of airborne generation straight through to localized cellular failure. The safety practitioner's objective is to engineer physical interventions that break that pipeline. We start by analyzing the physical form of the hazard. This diagram compares a human hair to common construction contaminants. A human hair is roughly 70 microns thick. Beside it, a silica dust particle measures less than 10 microns, and an asbestos fiber less than 3 microns thick, with a 3-to-1 length-to-thickness ratio. We divide airborne dust based on this 10-micron threshold. Particles above it are inhalable. Particles below are respirable. Because respirable particles are so small and light, they easily bypass the body's upper respiratory defenses and penetrate deep into the human alveoli, the tiny air sacs at the very bottom of the lungs. The mechanism of generation matters. Dusts are solid particles created by physical processes like crushing or grinding concrete. Fumes are entirely different. Fumes are microscopic solid particles formed by the condensation of vaporized materials, usually generated by high-heat processes like arc welding or cutting galvanized steel. Biological agents behave by the exact same aerodynamic rules. Bacteria like Legionella or fungi spores kicked up from dry bird droppings on steelwork act as respirable particles when suspended in the air. A hazard's physical form directly dictates exactly how deep it can penetrate the human body. This physical reality is the critical first variable you must establish in the NEBOSH control equation. Hazardous substances breach the body through 4 primary routes of entry. First is ingestion, second is skin absorption, third is injection via sharps, and most critically, inhalation. This graphic illustrates why inhalation poses the highest statistical risk on a construction site. The total surface area of an average adult skin is roughly 1.8 square meters. The absorptive surface area of the lungs is roughly 90 square meters. The body defends this internal surface using the mucociliary escalator. Sticky mucus traps large particles, and tiny hair-like cilia beat rhythmically to sweep that mucus back up to the throat to be swallowed or coughed out. The cellular breach occurs when respirable, insoluble particles, like silica or asbestos, are too small for the escalator to catch. They reach the alveoli, where white blood cells called alveolar macrophages attempt to engulf and digest the foreign bodies. This cellular defense mechanism is called phagocytosis. Because materials like silica and asbestos are highly toxic to these cells, the macrophage is distorted and killed. The lung attempts to repair this dead macrophage tissue by forming fibrous scars. Over years of repeated exposure, this massive accumulation of scar tissue destroys the lung's elasticity, resulting in irreversible chronic conditions like pneumoconiosis or asbestosis. That is a chronic, systemic effect. We contrast this with acute, local damage. For example, a bricklayer kneeling in wet cement experiences immediate tissue destruction and chemical burns directly at the site of skin contact. Depending on the substance, the body's reaction varies widely. Exposure to certain agents, like hardwood dust, can cause sensitization, which is a severe allergic immune response triggering asthma. Conversely, inhaling organic solvents from adhesives attacks the myelin sheath of the nervous system, causing toxic narcosis, marked by dizziness, loss of coordination, and suppressed consciousness. Occupational disease is the mathematical certainty of a specific route of entry delivering a physical hazard that overwhelms the body's localized cellular defenses. Before we can engineer a physical control, the law requires us to quantify the threat. In the UK, this is managed through the EH40 Workplace Exposure Limits, or WELLs, set under the NEBOSH regulations. A time-weighted average, or TWA, is the maximum concentration of an airborne substance averaged over a specific reference period. EH40 sets strict limits using 2 TWAs, a long-term 8-hour limit for chronic exposure, and a short-term 15-minute exposure limit, known as a STEL, to prevent acute effects like severe eye irritation. This brings us to a critical examiner trap. A safety data sheet provided by a supplier is never, on its own, a COSH assessment. It is simply the raw, unapplied data about the chemical compound. To build a site-specific risk assessment, safety practitioners extract data from the 16 mandatory headings of the safety data sheet. Specifically, Section 8 details the necessary exposure controls, and Section 11 outlines the precise toxicological information regarding how the substance damages human tissue. Here's the formula for calculating an assigned protection factor, or APF. APF is the realistic level of respiratory protection a device provides in the workplace. You calculate it by dividing the measured concentration of the contaminant outside the facepiece by the maximum acceptable in-facepiece concentration, which is the legal well. If a worker using a portable grinder is exposed to 20 milligrams per cubic meter of dust, and the legal exposure limit is 5 milligrams, dividing 20 by 5 gives you a required protection factor of 4. You must select respiratory protective equipment that meets or exceeds that specific mathematical threshold. Without taking quantitative measurements against legal EH40 thresholds, choosing a face mask is dangerous guesswork. In a NEBOSH exam, guessing equals failure. Once the hazard is quantified, we apply the hierarchy of control. Under COSH regulations, elimination and substitution are the mandatory legal first steps. You must attempt to remove the hazard entirely before managing it. Examiners look for highly specific substitution examples. Replace carborundum with sandstone, substitute highly toxic toluene for benzene, or replace asbestos with mineral fibers. When substitution is impossible, we move to engineering controls. This image shows a local exhaust ventilation system, or LEV. LEV systems are designed to physically extract the contaminant right at the source of generation, before it enters the general atmosphere. For an LEV to work on a portable tool like a grinder, the system's capture hood must generate a specific capture velocity. That suction velocity must be powerful enough to physically overcome the high kinetic energy of the debris being thrown off the spinning disc. Here we see asbestos insulation on pipework. When refurbishing licensed, highly friable materials like this, the engineering controls scale up to total enclosure, physically segregating the hazardous process from the rest of the site and the people on it. A licensed asbestos enclosure relies on specific mechanics. The work area is sealed inside a timber frame covered in 1,000-gauge virgin polyethylene. A negative pressure unit, or NPU, is then attached. An NPU is a heavy-duty extraction machine that pulls air out of the enclosure through a high-efficiency particulate air filter, ensuring any breaches in the polyethylene pull clean air in rather than letting asbestos fibers out. Workers enter and exit exclusively through a 3-stage personnel airlock. This brings us to the PPE fallacy. Examiners heavily penalize students who jump straight to respiratory protective equipment as their primary answer for airborne hazards. PPE is the absolute last resort because it is structurally weak. RPE requires individual face fit testing, it clashes with safety goggles, it requires rigorous daily maintenance and cleaning, and relies entirely on continuous compliance of human behavior. It only protects the wearer, leaving the hazard in the air for everyone else. The final backstop is health surveillance. This is a medical monitoring program designed to detect early biological effects of exposure, such as testing for diminished lung function in workers cutting silica, or monitoring skin sensitization in bricklayers handling wet cement. True hazard control relies on structural engineering and physical separation at the source. Relying solely on personal protective equipment represents a systemic failure of management. To succeed in Element 12, you must demonstrate a specific mental model. You must accurately match the aerodynamic and biological reality of a chemical or biological agent with a proportionate structural engineering solution. Avoid the common mistakes. Know the strict difference between a dust generated by crushing and a fume generated by condensing metal. Understand how respirable particles bypass the mucociliary escalator. And recognize that relying on barrier creams is an inadequate substitute for preventing chemical skin contact in the first place. Master the specific controls for the construction industry's major threats: licensed NPU enclosures and 3-stage airlocks for asbestos, local exhaust ventilation and wet suppression for silica dust, strict hygiene and glove management to prevent cement dermatitis, and carefully assess legacy hazards during refurbishment. Applying high heat to strip old, lead-based paint from surfaces like this skirting board creates highly reactive sub-micron lead fumes. These fumes bypass standard dust masks, enter the bloodstream, and destroy the myelin sheath of the nervous system, causing severe, chronic neurological damage. The NEBOSH examiner is looking for safety practitioners who understand that the primary objective is to physically control exposure, not just measure it, and not just file away a safety data sheet. True occupational health in construction does not rely on asking workers to wear masks. It relies on engineering the hazard out of the air they breathe.